In this video, we're going to go ahead and concentrate on solving a system of three linear equations involving three unknowns. And let's go ahead and take a look at the system that we're talking about. This is a system that involves some fractions. This is typically what you would see in an intermediate algebra class. And whenever you're solving a system, and let me bracket these up so it looks like a system here, instead of just having them all kind of lazily drawn out. Whenever you're solving a system of equations and you see fractions, you are more than welcome to get rid of fractions by multiplying each equation by the LCD in that equation. So for example, that top equation, if you look at all the fractions within that equation, the LCD is 4. And the next equation, the LCD of all the fractions in that next equation is also 4. And finally, the last equation, the LCD in all those, within all those fractions in that equation, is also 4. So I'll just distribute the 4's through here. And it gives me that we have the following system of equations. Let's see, when I distribute that 4 on that first one, I'll have 3x minus 2y plus 24z is equal to 4 times that 2. Oops, I forgot to write the 4 there. 4 times that 2 is 8. The next equation, when I distribute the 4, you get 2x, you get a 4y, and you get a negative 3z. And that's equal to 4 times 0 is just 0. And by the way, that's a common mistake I'll see. I'll see a lot of students that will multiply that 4 times that 0 and they'll write 4. You have to remember 4 times 0 is always 0. If you think you're not prone to making that mistake, I promise you are. I've seen it happen to the best. So don't make that mistake. Easier said than done. Alright, so now at this point that we have these very nice equations, we have to just decide which variable we want to kill off. To be honest with you, I think it's easier to kill off the y's than it is to kill off anything else. So I'm going to kill off the y values here. So let me highlight the column that I'm kind of aiming to work with here. Kill off all those values. So I'll take twice that first row and I'm going to add it to the second row. And at the same time, I'll take a negative 2 times the third row and add that to the second row. So when we do this, we'll kill off y twice and we'll get 2 equations, and in each of those equations we'll have just x's and z's. So twice row 1 is going to be 6x minus 4y plus 48z is equal to 16. And to that I'm going to add row 2, so that's 2x plus 4y minus 3z, and that's equal to 0. Add these up, we'll get 8x plus 45z is equal to 16. The other side over here, negative 2 times row 3, will give me negative 2x minus 4y plus 4z is equal to 0. And we're going to add that to row 2. So we have 2x plus 4y. Let's see, this is row 2, right? Minus 3z is equal to 0. You add these up, you get that the x's cancel, the y's cancel, and you just have a regular old z is equal to 0. Now, again, another common mistake. Students think that z being 0, or when they get a variable that turns into 0, that this all of a sudden has no solution. It's okay that a variable is equal to 0. It's absolutely fine that a variable is equal to 0. It just means that it makes your job actually easier, because then when you look at this equation right here, you know that z is 0, so therefore this just turns into 8x is equal to 16, or in other words, x is equal to 2. So we have z equals 0 and x is equal to 2 now. And now that we have x and z, we can substitute those into any of the equations involving x, y, and z. And I will choose to substitute these into, let's go into, sorry, my pen is being weird, into that equation right there. So x being 2 plus 2y minus 0 is equal to 0. Well, that means 2y is equal to negative 2, or in other words, y is equal to negative 1. Whoops, it's supposed to be a negative 1. Alright, so our solution is 2, negative 1, 0.